Welcome back, everyone. So this section is all about collaboration workflows, different ways of configuring a repository and different ways of working on branches, when to create branches, how to merge changes, how to ask to merge changes, how to get permission. We won't be seeing any new Git features, or new Git commands rather, but we will be spending kind of a lot of time talking about workflows. I considered breaking this up actually because it is a long section, and I recommend that you take your time and probably I would split up viewing this section, maybe even go on to some of the later concepts like rebasing or Git tags if you want to break, something that's a bit breezier, and then come back to finish up this section because it's all pretty important stuff, but it's also just a lot. Okay, so we're going to start by talking about the problems with working in what I call a centralized workflow, working on one branch. It's important to understand. Then we cover the feature branch workflow, critical. We talk about something called pull requests. Very important if you plan on working with collaborators, if you plan on working on open source projects, if you want to use Git in some sort of work environment where there are other people, PRs or pull requests are used all the time. I put branch protection rules in important. This is a thing we can change, a setting on GitHub. It's important to know about, but just not as critical as these other things. I'm going to show you something on GitHub called forking, and then we spend a decent chunk at the end of the section, three or four videos talking about forking and a workflow called fork and clone. That's what I call it, at least. And this is heavily used for open source projects, big projects like React or VS Code, which is open source, TensorFlow, just any big open source projects you can think of that have thousands of collaborators. They don't grant every collaborator full permissions just to push up. So the fork and clone workflow is employed in those scenarios, and it's worth knowing about if you plan on making open source contributions, which is always a good idea. Anyway, there's a lot of stuff in this section, all workflow oriented, lots of diagrams. I'm pretty proud of some of the diagrams, gotta say. Take forever to make them, but I think, hopefully, some of them are useful. Let's go ahead and get started. You be the judge of that. Okay, bye. So the first of these collaborative workflows, I'm calling the centralized workflow. It's not really an official name or anything, but I'm telling you now, it is the weakest. It's the worst of these workflows for collaborating. And the reason I'm showing it to you is that the shortcomings of the centralized workflow are addressed by the other workflows that we're going to discuss. So we're kind of motivating the more complicated workflows, but we're starting with the simplest. So I'm calling it the centralized workflow, aka everyone works on the master branch, or everyone works on the main branch, or everyone works on some single branch. So that's why it's super easy. It's centralized because all the work is done on a single branch. Whatever that branch is, historically that would just be the master branch, a default, but it could be any branch. So it's straightforward, right? We don't have to worry about pushing up a whole bunch of different branches and pulling them down and merging different branches. We just work with one branch. So I have some diagrams that I'm going to be using throughout this section. They all kind of follow the same pattern. Up top, we have three different collaborators, Pamela, David, and Forrest. And I'm highlighting one of them to indicate whose repository we're looking at on their local machine versus up top in the right corner, this is the GitHub repository that all three are using. So this is the same repo on GitHub for everyone, but then we have three different local repositories, but they're all connected to that same GitHub repo. And I have similar diagrams for the other workflows, the same characters, the same format. So with this centralized workflow, everybody clones the same repository. So this is our starting point, just one commit. So Pamela clones it down, right? There's the master branch or the main branch, whatever we want to name it. It's the same branch. So David clones it. He gets that default branch master. Forrest clones the same GitHub repo, and he has it. So now they get to work. Forrest, this guy here with the mustache, spends his day adding and committing. He's working on some new feature. He has 2 new commits. So this is what he started with here. He has 2 new commits worth of work on the master branch. So he wants to share that with everyone, right? He pushes that up. So you can see those new commits. There's now 3 total commits on GitHub. During this same period where Forrest was working and he pushed his code up, Pamela has also been hard at work on her own feature all day. So that yellow commit is Pamela's new work. Okay, so as she's been working, Forrest already pushed some code up. Pamela now wants to share her code with everyone. So she wants to push it up. So she tries it. Git push origin master. But she's not allowed to. Why? Well, she gets this message. Failed to push. Updates were rejected because the tip of your current branch is behind its remote counterpart. Merge the remote changes, git pull, before pushing again. So Git is telling her, I can't do that. There are changes that you don't have on GitHub. You need to get those changes and merge yours with those changes, and then you can push back up. So already we hit a roadblock, right? Just for Pamela to push her code up, she has to pull down everything that her other collaborators have pushed up. They're all working on the same branch. So she does that. She pulls down, she gets the changes that Forrest had pushed from on the master branch from GitHub. Then she merges her work in, and hopefully that goes smoothly. There might be a bunch of conflicts, maybe not, but she has to do it. And then she can push back up. So now there are 4 commits up on GitHub, or more, but a minimum of 4, although I didn't really include, there would be a merge commit here. So let's say 5, but whatever it is, she pushes up her new commits and she's good to go, right? That's her part done for the day. Now, during all of this, poor David has been working on a new feature, but he's been having some doubts. It's not working. He's really like halfway done. He's deleted a bunch of important files. He's commented out some code. Things are broken. So he wants to get some input, some advice from his collaborators. He wants to start a discussion, and he wants them to see the code. They're not working in an office together. So he has this work, and he has some commits indicated by this meh face. This, I guess, I would call it a meh face or a neutral face. I don't know. Anyway, he's not happy with it, but he makes a commit, and if we're using this centralized workflow, one branch. So he's just working on the master branch. So in order for him to share this, he can't just push it up because, as we saw, Pamela earlier tried, and Git said, no way, you can't do that. You've got to pull down, get the changes, then merge, and then you can push. So that's what he does. Before he can even share this mediocre, unfinished, broken code, he has to first pull down, get all the new changes, and merge his broken stuff in, his incomplete feature. He has to merge that in with the rest of the work everyone else has done on the master branch. Then he can push that up. And now everyone can go and pull his work down. And he broke the code base, probably. If this is incomplete, everybody now has that incomplete code. And that's really frustrating and problematic. All he wanted to do is get some input and have some of his collaborators, take a look at his work. But to do that with this workflow, he had to wreck the master branch, the one and only branch. So hopefully the problem is clear with those diagrams. It's simple. You don't have to think about where you're working if you're only working on one branch, but there are some serious issues, some shortcomings. First of all, every person has to spend a ton of time resolving conflicts or at least merging code, especially as team size scales up. Imagine you're working with, let's say, 10 developers, and at the end of the day, everybody makes a bunch of commits, they push them up. Well, for each one of those developers to make those commits and push them up, they first have to pull down everyone else's work just to merge their stuff in. So it's a lot of merging and potential conflicts, even if work is not entirely finished. So that brings me to the next piece. No one can work on anything without disturbing the main code base. How do you try some radical experiment? How do you try removing files and commenting things out, trying to fix some crazy, difficult bug if you have to work on the master branch? How do you experiment? And that brings us to the last piece. There's no way to really collaborate on anything unless you push incomplete code up to master. And now all your other teammates have incomplete or broken code, which is what happened here in our final scenario. David wanted, is this David? Yes, David wanted some help. He wanted to collaborate with, let's say, Pamela. For her to get that code, he had to add stuff onto master that's broken, push that up, and now the whole code base is broken, at least at the tip of the master branch. Everyone else comes to work the next morning, they get the most recent changes. Oh, things are broken for everyone. So not a good workflow. It can be manageable if you're a very tiny team and you're not doing anything experimental. Even then, I wouldn't really recommend it, but it is an option. So that really serves to highlight the problems with working on one branch, which now motivates us to talk about workflows that involve multiple branches. That's coming up. In the next video, I want to demonstrate some of these problems for real using a GitHub repo. Okay, here goes nothing. I'm going to demonstrate the centralized workflow. I'm working with the same two user accounts, same two Git users, Colt and good old Stevie Chicks, my chicken. Well, you can see Stevie Chicks. That's who I'm signed in here. Once again, pay attention to what you see up top. That is very important to differentiate between the different users. All right, so I've made a repo called Centralized Workflow. Colt is the owner. And I've gone ahead and added Stevie Chicks as a collaborator. As you can see here, I just fast forwarded, or I didn't even fast forward. I skipped through that part entirely because it just takes time. I had to open the email and accept the invite as Stevie. But anyway, we both have access. It's a public repo for now. It doesn't matter. And Colt's already added a simple README. And I actually did that all in the browser. I don't have this on my local machine. So I am going to clone this down as Colt. So make sure I'm not in a Git repo, Git status, cool. So git clone that URL. Okay, so now we have that folder, Git status, we've got the README, and I'll open that over here. Okay, so there's that file there, and then I'll go ahead and clone the same repo down to Stevie's local machine so that we can, both work on it just like we would, just like in the diagrams where in this centralized workflow, everybody clones or everybody gets the same starting repo, the same remotes. So that's what I'm going to do here. Okay, so I'm going to copy this URL and then as Stevie, clone it. Okay, and just as a reminder, I had to jump through some hoops in order to have these two different accounts and be able to clone as separate users with different SSH keys. So I actually did tweak my URL a bit to make this all work. It doesn't really matter because I'm not expecting you to do it, but I just want to be very clear and transparent about that. I am on one machine, and normally you don't have two different accounts and two different SSH keys and all of that. Anyway, I clone that. We see centralized workflow. Great, and we're now working on that. I'll open it in Stevie's editor too. Okay, so now we both have it. We've cloned, we're ready to go. So we're gonna make a simple website. I'm talking very, very simple, and Colt is gonna start it off. Colt is going to make the index.html, our main file, the entry point into our app. And then he's going to add and commit that. So we'll do a git add index, git commit-m, add index.html. I'm doing super short and kind of terrible commit messages, but that's fine. And then what I'm going to do is use Bootstrap. So if you're familiar with Bootstrap, great. If not, it doesn't really matter because I'm not expecting you to follow along. But I'm going to open that HTML file and add some basic Bootstrap boilerplate. Okay, so I put that in there, and I'll add and commit that as Colt, git add index, git commit, add Bootstrap boilerplate. All right, so now I'm going to push this up. I'll clear. I'm going to push those two commits to origin main. If we're all working on one branch, in this case, it will be the main branch, but in the diagrams I created, it's the master branch everyone's working on, but it's the same concept. So basically, right now, we're playing the role of Forrest, doing some commits and pushing them up. All right, so that's what I'm going to do, git push origin main, and that goes up to GitHub. And now if we refresh our repository, we see index.html, right? This is now up here. So now as Stevie, we definitely want to pull down those changes, right? So git pull origin main just to start. All right, and so now we have that new file, index.html, and let's get to work. Let's say that Colt has been tasked with making a form on their web page, a simple form. So we're just going to copy some of the forms from the documentation. Maybe it's a form that looks like, sure, maybe it's just a login form. So we're just going to copy this just to keep everything short. So this is on Colt's machine. We'll put this in the body. We'll add a Bootstrap container. Okay, so this is the work. We'll pretend this took all morning. Colt did this work. So then Colt decides, it's so weird saying my name in third person, but anyway, I decide it's time to make a commit. So always check git status. All right, I'll just do a one-liner, git commit -am. for, what did we do? Add basic, is it a login form that we made? Sure, login form. All right, so now Colt pushes this up. He wants everyone else to know about this. So git push origin main. Now, at the same time all of this has been happening, Stevie is working on some other feature. Stevie has been tasked with adding a navbar. Probably not exactly right, a super realistic reflection of a real workplace where one person is asked to just put a form on a page and somebody else is asked to independently put some random navbar on a page and then they're expected to combine it. Usually there would be some sort of design process and some sort of mock-up or wireframe or something that would be what we were trying to recreate. But anyway, let's just say it's a free-for-all. Stevie has been asked to add a navbar. So on Bootstrap, we can make all sorts of fancy navbars like this one here. Again, I'm just going to copy this. Just straight up copy it. I don't want to waste your time. So Stevie, this is Stevie's desktop here, puts that in index.html, puts it right above everything else. So this is Stevie's work. Let's see what it looks like if we refresh. There's the navbar. Okay. So then Stevie adds and commits that. Git add index, git commit -m, add, bootstrap navbar. Okay. So then he keeps working, and then maybe he makes another small tweak. He actually wants this to be a dark navbar. So on the navbar, we can change this navbar light to be navbar dark, and then give it a dark background. So BG dark, like this. Let's see what that looks like. All right, so that's what Stevie wants. And then he realizes, oh, you know what? This is supposed to be responsive, and it is, except why is this drawer not working, right? He wants this drawer like it does on the documentation. Whoops, it's on this page, isn't it? On the documentation, when this collapses, right there, there's this drop down that's supposed to show up, or this drawer that expands. But it's not happening on Stevie's copy, and he's freaking out. He's very junior. He's a chicken. He doesn't know what's going on. So he decides, you know what, I should just ask Colt. He's somewhat experienced with this. I'm going to just ask him. I'll send him a Slack message, and I'll put my code up on GitHub. So you probably know where I'm going with this. Stevie needs to put this code on GitHub. He wants to put this it's working. It's a navbar. It's showing up. But for whatever reason, it's not collapsing. He wants to share this with Colt. So Stevie goes ahead and adds and commits. He needs to add that. Git add index, git commit -m, change navbar color to dark or something. All right, so now Stevie, moment of truth. I'll make this a bit larger here. Now he pushes this code up. And if we're doing this centralized workflow, if there's only one branch, main, he pushes that up. So git push origin main. Uh-oh, what does this say? Rejected. Oh, who saw this coming? Failed to push some refs to blah, 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 blah. Updates were rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing blah, 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 blah. So basically, we ran into this problem. Oh my gosh, lots of desktops right here, where if we try and push something up and we don't have all the new work from GitHub, Git won't let us do that. So we first have to pull those new commits down. Basically, I have to get the work. Stevie has to get the work that Colt pushed up to GitHub. Oh boy, what a nightmare to talk about all of this. But right, there's these new commits. There's 5 commits here. The most recent one is the login form that Colt pushed up to GitHub. Stevie doesn't have that locally. So we have to pull down. So we can do that. Git pull origin main. And it could have been worse, but there was still a merge. So we have this merge commit, and it's saying merge branch main, blah, 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 on into main. Sure, we'll just go with that. So this is what things now look like on Stevie's machine. He got the changes that Colt did for this form. So now he can push up, hopefully. Let's see, git status. Yes, he's good to go. So he can push up, git push origin main, which is what we tried to do in the first place, right? We don't even have this finished navbar. It's still not really working. We want to push that up. Okay, we go to GitHub and it does show up here. we can see on index, we have the navbar content. So in the meantime, it's the next day, Colt shows up to work and he starts doing some other stuff. Let's say he's just making some minor tweaks. He's changing the form. I don't know what he's doing to the form. Instead of, we'll never share your email with anyone else, we'll always share your email with everyone. So he's just making some changes. And then he gets that message from Stevie saying, hey, I just pushed up some new code, this broken navbar. Can you try and fix it for me? So Colt then has to decide, okay, well, I have these changes, right, on my master branch or my main branch, the only branch allowed in this workflow. Oh, you can see it's kind of a nightmare. I have changes that are not ready to commit. What do? I want to go get that new stuff from Stevie. But if I try and pull right now, get pull origin main, and what do we see? Oh, it doesn't actually let me do it. It says your local changes to the following files would be overwritten. Please commit your changes or stash them before you merge. So it doesn't even let me get the newest version, the newest work that Stevie's done. So I need to commit or stash. I guess we could stash, but that's fine. So git stash. Okay. So now I can take a look. I can do a git pull origin main again. We're all just working. We're stuck on this one branch. All right. Now I get that new commit, hopefully from Stevie. Let's just take a look. We have the navbar. It is showing up and it's not working, right? I go back here. It's still broken. And that was the point. Stevie wanted help. And just to get help, he had to break the main branch, our only branch. I mean, it's not truly broken, but he had to add this incomplete code to it. This isn't working, and it's not ready for production. I'll get in trouble from my boss. I can't do this sort of thing. So in the next video, we're going to talk about a much better workflow. Okay, so as we've seen, the centralized workflow, aka everyone works on one branch, is not ideal. Quite a few issues. That brings us to our next workflow, feature branches. I don't really know what to call it, but that's the concept. Work on feature branches. Don't work on master, you silly goose. That's the main idea. If the centralized workflow is everyone works on master, the feature branch workflow is nobody works on master or main, you always work on a feature branch. This is a very, very common pattern. Rather than working directly on the master branch or the main branch or any centralized branch, all development, whether it's something tiny or some massive new feature or a redesign or a bug fix, all development should be done on separate branches. So part of this means treating the master or main branch as the official project history, the branch, right? Like the sacred branch that you're not going to work on. Instead, all work is done on these side feature branches and then merged back in to the master or main branch when appropriate. This allows multiple teammates to collaborate on the same feature without having to mess up the master or main branch, like with what happened with the centralized approach. To share broken code or incomplete code also meant breaking the master branch. So with this feature branch workflow, I could have a branch that never works. It's always broken, and I can collaborate on that with anybody else, any number of collaborators. So my master or main branch should not contain any broken code unless somebody messes up and, thinks code is not broken and they merge it back in and it actually is broken. So back to our diagrams. Here's the same three characters, Forrest, David, and Pamela. They all clone the same GitHub repository. It starts with 2 commits and a master branch or a main branch. In this diagram, master is the default branch name. So Forrest clones it, Pamela clones it, and David clones it. Everyone's at the same point. Okay, so we work on feature branches. David starts working on a new feature. He's working on a branch called Add Dark Theme. So he's hit a point where he's not totally done. He's maybe 30% of the way there, but he wants to share his work with the rest of the team. And specifically, he wants some help from Pamela. He wants her feedback, or maybe he wants her to write some code. So he pushes his branch up. He pushes Add Dark Theme up to GitHub. So he didn't merge it into master, right? It's not merged into anything. He just pushes that feature branch up to GitHub. So at the same time, during this morning or afternoon or whatever it is, Pamela has been working on her own new feature. Animated Scroll is the name of the branch she's working on. It's a totally separate branch. It's in yellow here to make that clear. She's not working on master. Nobody works directly on master or main. So she's working on her branch. She's made good progress. But then she gets a chat message from David. David sends her a Slack saying, hey, Pam, can you please take a look at the work that I did today on the branch, what was it called? Add dark mode. Is that what it was? Add dark theme. Can you take a look at that branch, pull it down from GitHub, and let me know what you think, and add some of your own work? So that's what she does. She pulls down that branch. She didn't have to stop what she was doing and merge this into some other branch. She can just leave her animated scroll branch where it was if she's not ready to share it, and she just pulls down his branch. So we've seen how to do that, how we can switch to a remote branch. We can fetch to see if there are new branches that we don't have and then switch to them. So she gets his feature branch down, add dark theme, and it doesn't pollute the master branch. It doesn't pollute her animated scroll. They can coexist side by side. So she takes a look, she makes a couple of improvements. She even adds her own commits on the same feature branch. So it was 3, now it's 4 commits. So she pushes those up. Add dark theme is now updated on GitHub. She tells David, hey, I added some new work. Go ahead and pull down those changes. And so he returns to work the next morning. I guess this was late at night or evening. And after some Redditing in the morning, he decides, okay, I guess I should get back to work. But all that he has are these 3 commits on add dark theme. All he needs to do is pull down, see if there's any new information. I mean, he could fetch first to check, but he gets the new work from that branch on GitHub that Pamela did. And now he can continue his work. And then at some point, maybe he decides he's happy with the new feature and he can merge it into master. So that's what I'm illustrating here. So that actual mechanic or mechanism for merging into master, usually you don't just decide. If you're at a big company, you don't decide, all right, this goes in master. There are usually some controls. I mean, at the very least, there's code review. Somebody or a team of people need to look at what you've written, right? Things need to pass tests. So it's not a matter usually of just merging it in whenever you want. And we'll talk about some of those mechanisms for code approval and rejection, but that doesn't really matter for this workflow right now. All that matters is that when a branch is done or when a feature is done, it can be merged into master. So this would ideally, in the way that this is supposed to work, this is a fully done feature. It's not broken. It's ready to go. Then we merge it into the main branch or the master branch. We don't merge broken stuff in, unlike the previous centralized workflow. So everyone works on a branch. On a given feature, you could have multiple branches too. It's not necessarily like Pamela's branch and David's branch. It's more one branch per feature or branch per bug fix. Branches are feature oriented. So this allows us to then share those branches, collaborate on branches, and keep our master or main branch as the source of truth in our repository, as the stable, always working, functioning, non-broken branch in our project. And of course, the last thing that would need to happen once David merges his new feature branch in is he would push that up so that GitHub is updated. And now everyone's master branch would include those new commits, those new changes that he made on his feature branch originally. So that's the main idea. Master or main or whatever you want to call it, you treat it as a branch that is not to be screwed with. It's the official project history. All work is done on separate branches, and then those branches can be either abandoned or eventually merged back in to the official project history, whether that's master or main. Remember this slide from the centralized workflow. These were all problems with working on one branch. No one can work on anything without disturbing the main code base. That's not a problem if you're working on a feature branch. The only way to collaborate on a feature is to push incomplete code to master. Nope, that's not a problem now if everyone works on feature branches. Way less time spent resolving conflicts and merging code, because now code only needs to be merged when something is ready to go into master, not anytime anybody does literally any commits, which is what happened when everyone works on one branch. Okay, in conclusion, feature branches, much better approach. All right, so I'm going to do a demonstration of working on feature branches and collaborating between the same two people, me, Colt, and Stevie, the chicken. So I've made another repository on GitHub called Creatively Feature Branch Workflow. I've already added Stevie as a collaborator and I've accepted the invitation, so Stevie shows up there. And I've been working on this repo locally as Colt. So I haven't done much. This is all that we have. If it's the same thing, a Bootstrap website, just basic Bootstrap included and a heading that says Hello World. So again, we're not trying to like go crazy with some fancy code or anything. I'm just trying to show the workflow. So in the last example, it sucked working on the master branch or on the main branch. I had to pull down and merge code before I could ever push my code up. We broke the main branch because Stevie was trying to share some incomplete code to get feedback and hopefully get it solved. Anyway, that won't be a problem if we work with branches. So I also cloned it down from Stevie, right? This is Stevie's side as it shows you there. I cloned it down and we're working on it locally as Stevie. So why don't we say Stevie gets to work on a navbar? Same thing as last time. Now he's not going to work on the main branch. Instead, he's going to create a new branch. We haven't really talked about naming feature branches. I'm going to keep it very simple and do something like navbar or add navbar. There are lots of patterns that large companies and organizations follow for feature branch or just branch naming in general. You might see things like feat for feature / navbar, for example. And then you might see something like bug or fix or refactor, different prefixes. But I'm just going to go with a very simple one. We'll just call it navbar. So we'll do git switch -c to make that new branch, navbar. Okay, and again, I'm logged in right now as Stevie. I'm working as Stevie. So on this branch that we're currently on, I can go ahead and try adding a navbar. So we'll do the same thing as last time. I'll copy that very large navbar from Bootstrap. I'll put it up top. Let's see what that looks like. Okay, there's our basic navbar. But once again, it's not working the way it's supposed to. What's going on? Well, I would like to share this with Colt and, get some feedback from him or from anybody on the team, see if they can fix that issue. I'm not going to merge it into master. I'm simply going to take this branch. I'm going to add and commit my work on this branch because I can have incomplete or broken stuff on a branch. No one cares. My master branch or the main branch is supposed to be the source of truth branch for my application. So I'm going to add and commit as Stevie. So git add index, git commit, begin navbar or add broken navbar. Okay, so now I can push that up to GitHub if I want to. I probably wouldn't push that up as just a broken halfway working navbar, but if I wanted to get feedback or collaborate with a teammate, which is what I'm going to demonstrate, then I definitely would push it up. So I'm going to do that now. We have our remote, right? We have origin, and I'm going to push the branch navbar. So git push origin navbar and push that up. I refresh, and we already see, okay, navbar has recent pushes less than a minute ago, and I can see my work is showing up here on navbar by Stevie Chicks. So I preserve the state of main. I don't have to screw up main, and I can still share code that is incomplete. Meanwhile, Colt is working away on his own feature, and so he's on his own branch. What is he doing? Let's say he's working on a pricing table like you see here. This is just one of the examples from Bootstrap. If you go to examples. So I'm going to start, before I go any further, by making a branch that we're going to work on. So if we're trying to make this pricing table, let's make a branch called pricing table or something like that. So I'm now switched back to Colt, and I'm going to just check. All right, I'm on main. So the first thing I would always do is just see if there's any updates or any new changes to main before we branch, because we want the most recent version of main. Maybe a coworker has merged something into main and I don't have it. So we could always do git pull origin main, although there's nothing new up there. We're already up to date. But now I can make my branch without having to worry that I'm missing commits. Anyway, git switch -c, let's just call this pricing table. Okay, so I'm on this new branch, and now I can do some basic work. I'll do maybe 2 commits. So the first one, I'm just going to add a container to work inside of. If you don't know Bootstrap at all, again, that's not the point here, so please don't worry about it. But I'll just do very basic, simple commits. Like you wouldn't commit that, just a single HTML element, but I will here. So git add index, and then I'll do git commit, add container, do index. Okay. Now let's do another commit where I'm just going to copy the markup from this example on Bootstrap to make this pricing table. I'll inspect, And then let's see if I can make this larger for you. I want this right here. So I'm just going to right click, copy, and then copy outer HTML. I want the whole thing. Whoopsies. Not just the particular element, but really it doesn't matter. This is not a course on HTML or copying and pasting, but I'm going to paste that inside, pretend that I've been working on that all morning. Okay, so that looks fine enough, right? And the good news is that if I want to share this, maybe I'm not done, but I want to share it with somebody and push it up to GitHub, I can push this branch up at any point. It doesn't matter what other people have done. Unlike with our first workflow, where I couldn't push anything up until I had pulled down changes to main or to master, and I had to merge, and that process repeated anytime anybody pushed new changes up to GitHub. Everyone else has to pull them down and merge before they can push. But that's not an issue here. So now I can push my branch up if I add those changes. So git add index, git commit, add pricing table. I'll just go with that. Okay, and now I can push that branch up. Git push origin pricing table. And we'll go back to GitHub. And now we have two branches up here, navbar and pricing table. Okay, so I'm not necessarily suggesting that every time you make a feature branch, you need to push it up to GitHub. A lot of the time you won't do that unless you have a particular reason and you need to share that feature branch with somebody. But often if you look at an organization's repositories, they're not going to have thousands and thousands of branches, even though there have been thousands of feature branches over probably a month or a couple of months at least. There's just tons and tons of new branches all the time. We don't push them all to GitHub. If we do, we remove them, but also just a lot of the time you don't need to push them up to GitHub. You will merge them in to master or to main at some point, and then just delete the branch when you're done. So they don't need to stay around if you end up merging that stuff in. Anyway, sticking with Colt, let's say that now Colt gets that Slack message from good old Stevie saying, hey, I pushed up that navbar. Could you take a look? I don't know why it's not working. It's supposed to collapse, and it is, but it's not expanding on small screen sizes. I'm not getting the drawer that I'm getting on the documentation. Why is it not working? So Stevie's just a chicken. What do you expect? I'm no expert, but I think we can figure it out. So what I need to do is pull that branch down, right? And before I do that, I could just fetch. So I'm on Colt again, just to be clear. I can do a git fetch origin and just get everything from origin. Has anything changed? And yep, it says new branch, navbar. So we have origin/navbar. And I could start by just going into detached head, I'm trying to make this a bit larger here, and checking out. If we do git branch-r, we see there's this origin/navbar remote tracking branch reference. So I could check that out, git checkout if I wanted to, origin/navbar, detached head, but I can take a look and here it is, right? I can refresh. This is what's in my working directory because I'm in this detached head state, and I can verify, is it actually broken? Well, it's collapsing how it's supposed to, but that's not working. So, okay, I see Stevie's right. Something is going on, and I want to work on that branch. I want to make a contribution as Colt on that navbar branch. So I need to leave detached head. Let's just go back to where we were. We can do this git switch dash. So now I'm back on pricing table. And then if I want to check out that navbar branch, remember with git switch, it's super simple. I can do git switch and then just the same name. So navbar, Git will automatically make me that branch navbar, even though it doesn't exist on my machine yet, and set it up so that it's connected, it's tracking origin/navbar. So here we go. It tells me exactly what I just said, branch navbar set up to track remote branch navbar from origin. So now I'm working on the navbar. I'm not just in detached head, and I can start to, try and tweak it and figure it out. I happen to know what the problem is. This requires Bootstrap JavaScript, which I did not include. So let's say that was an accident. A very trivial, simple to fix issue, but most anybody would notice that in a matter of seconds. I didn't include the JavaScript file. So I'm going to go get that from Bootstrap. Just right here, let's take that script. Okay, I'm going to go put it just at the bottom of for HTML. Now if I refresh, hopefully it works. And indeed it does. So we just collaborated, Colt and Stevie. Stevie started the navbar, Colt hopefully finished it. I hate saying my name in third person. Now I'm going to add and commit that change to the navbar branch as Colt. So here we go, git status, git add index, git commit. We'll just go with, add fix navbar bug, even though it's really not a bug. It was just missing the entire JavaScript that it needed. Anyway, we'll pretend I just fixed some bug for Stevie. And this is on the navbar branch. So now I can push that branch up, git push origin navbar if I want to. And then I can go back to whatever I was doing, which was the pricing branch, right? What was it, pricing table? So now I'm back to that. I'll refresh here, completely different thing. And I can get back to work on this, right? I can experiment. I could do some radical new thing. And on GitHub, we now have the working navbar, hopefully, that navbar branch. And Stevie can now go pull that down and maybe keep working on it. Who knows? So on Stevie's machine, that's where I am right now, he hears from Colt that he fixed the bug in the navbar. So Stevie's going to go pull down the most recent changes, or maybe just the navbar branch. So git pull origin navbar. All right, fast forward because there's a new commit. If we type git log, we see the whole history here. Most recently, we have Colt fix navbar bug, and I'm currently acting as Stevie. And we see, if I expand that, the JavaScript is correctly included. And if we refresh, hopefully it works on Stevie's machine, and it does. So that's the basic idea. We're working on branches that allows us to collaborate more freely. We can experiment, try radical changes. We treat the main or the master branch or whatever branch, some branch, as the important golden child branch that we don't want to screw up. So we make feature branches. We make all sorts of branches. It doesn't just have to be for a new feature, but we make branches that we work on. Often people just call them feature branches. The thing that we have neglected to talk about with working on feature branches is the inevitable merging of those feature branches, or at least some of them. We need to merge them into the master or main branch. And how we do this is up for discussion. That's what we're going to talk about next. So I just spent all that time demonstrating working on feature branches, but so far, none of the work that Colt/me did or Stevie did, none of that work is integrated into the main branch or the master branch. So that obviously is an important part of working on feature branches, is integrating your changes in. And we have a couple of options for how we do this. One would just be merge at will. Whenever anybody wants to merge their changes in, just go for it. Just merge them into main. Obviously, that could be fraught with problems, especially on larger teams with lots and lots of collaborators, lots of new features. If there's no testing going on beforehand, if there's no conversation or discussion going on beforehand, that could get way out of control. And you would never do that on a real product with users and, things at stake. Maybe on a fun hobby project with friends, I guess. So another option that's similar is you merge your own branches in, but only after you have discussed it. You've sent an email or a chat message or some sort of had a conversation with your team in some way about whether you should merge those changes in or not. And then there is the third option, which is what we're going to talk about in the next video, something called pull requests. But first, I just want to do another demonstration of merging. So if you want to just get to pull requests, skip this video, but I'm just going to quickly demonstrate on Colt's computer. We have this pricing table branch, right? This is what the pricing table branch looks like, but the main branch currently doesn't have any of this. So let's say I've talked it over with Stevie. We're just a two-person team. Well, one person, one chicken team. And I say, okay, I'm ready to merge this in, I think. Let's say Stevie pulls it down. Stevie takes a look. We consent. All right, let's merge it in. Somebody merges it in. Let's say it's me. I'm the owner of the project. So I'm currently on the pricing table branch. I'm going to switch to master, to main, old habits. And then it's always good to just pull down to see if you've missed anything. Do we have any new work from main? No, we don't. Okay, so now I'm just going to merge And what is the branch I'm trying to merge in? Pricing table. And it looks like, well, easy. Fast forward. So nothing bad, no commits, no conflicts, no merge commit needed. Fast forward merge, and we see the pricing table shows up here. Great. I'll refresh my view here. I'm now on the main branch. We see the same thing as before. Okay, so we just integrated that feature branch, and now I can push main back up to origin main. So I'm going to do exactly that. Git push origin main. And then we'll go to GitHub. And now main includes the code from, no, I'm on the wrong branch. Main includes the code from pricing table. We see whatever work I had done, it's now on this branch. So nothing new, we just merged. And then on Stevie's side of things, wherever he lives, the next step for him would be to make sure to get that new version of the main branch. Whenever he goes back to main or whenever he needs that new work, go back to main branch. So git switch main. He could fetch or he could just pull. Git pull origin main. And now Stevie has this new work on his main branch. He has the whole pricing table and all of that stuff. And then he could merge in his navbar branch if we both agree it's appropriate. He could merge in navbar into main and then push that up, and then Colt would then go pull that down, and we'd repeat over and over. So that's just a quick version of merging a feature branch in. It would be best to delete that branch locally if we agree that it's, we're good to go. We merged in pricing table. We don't need that branch anymore. Delete it off of GitHub. But just to keep things short and easy for you to follow, if you do take a look at this repository, I'm not going to delete that branch. This way you'll just have that history. And in the next video, we're going to talk about the more common way of merging feature branches in or requesting to merge them in, which is a pull request. So now we get to talk about pull requests. This is the first of a few videos on the topic. I'm just going to start in this video by talking about what pull requests or PRs are and why we want them or why they exist. And then in subsequent videos, we'll make our own. Okay. So we talked about this concept of working on branches and how that makes our life a lot easier. But then at some point, somebody needs to merge those changes in from a feature branch into some main branch, master, main, whatever, right? We don't just stay on separate feature branches forever. Otherwise, everyone would be working in a silo and never merging and sharing their code, which defeats the whole collaboration thing. So rather than just allowing a free-for-all merge, especially if you're at a company where the stakes are high and you can't afford to screw up something on the main or the master branch, you have users, you've got, even if not that, if you've got hundreds of developers and somebody includes some bad commit or something that breaks things on the main branch, at the very least, you've got 100-something developers who now have a bad version of that main branch and they have to get rid of a commit or reset. It's just annoying, and you want to make sure that whatever you are merging in or whoever is doing the merging has some discussion around it, has some approval, maybe changes are made at the request of somebody else, right? There's some code review process involved, and pull requests or PRs are an integral part of that process. So pull requests are not a native Git feature. They are built on top of platforms like GitHub and Bitbucket and some others, but really most people are referring to GitHub these days. But again, not exclusive to GitHub and 100% not part of Git itself. So pull requests allow developers to tell other team members, other collaborators, that they have some new work that they want to be reviewed. New work that is on a branch that they want to be discussed, accepted, aka merged in, or rejected. And this facilitates discussion. They can get feedback. They can even update the work on the same pull request. So think of it as, hey, everybody on my team, hundreds of people, I have this new branch with this feature I just completed, or I think it's complete. It's on GitHub. I'm making this request, this pull request. Can you take a look at it and will you merge it in if it's good, or will you tell me if it's not good? That's pretty much what a pull request is. So we do some work locally on a feature branch like we did in the last couple of videos. Stevie added the navbar branch, right? We finished the navbar, we push it up to GitHub. Instead of just merging that directly into master or into main, In a lot of companies, actually, the main branch is protected. I'll show you how to do that. You can't just merge stuff in. You actually have to make a pull request so that there's an opportunity to discuss and accept or reject your changes. Somebody makes that decision. Maybe multiple people actually have to consent and actually approve of your changes. So once you make the pull request, you then have to wait for it to be approved and hopefully merged or something. Discussion, it might be closed, it might be ignored, but hopefully not. So here's an example with some diagrams. I'm working on this feature, I finish it, I push it up to GitHub, and I want to open a pull request. So on GitHub, there's this new branch, my new feature, and you've probably seen this before. Compare and pull request, it showed up a couple of times when we push branches up. That is a button I definitely want to click to make a pull request. Or I can also click it here. There's a couple of different ways of doing it, but if I click pull request, I then have this option to choose what pull request am I making. Well, I am requesting that my branch, my new feature, be merged in to master or to main or whatever the default, or it could be any other base branch, but typically we're talking about master/main. So then I need to provide some information, right? I need to come up with a name for what my pull request is, what's the reason for it, what does it include. Depending on the company and the organization, there can be some pretty strict rules for what goes in here. And then I can click create pull request, and then I wait. So in this hypothetical world of these slides, I have a boss, and my boss is the only one who can approve changes, who can actually merge pull requests in on GitHub. There are different ways of configuring permissions and all of that that we can get into, but basically my boss has to accept my pull request. I, as just an employee, I actually don't have the ability to merge directly into master on GitHub. I'm supposed to make a pull request. So my boss finds some issues and she actually leaves some feedback. She asked me to make some changes, ping me when it's ready. I can notify people or I can mention people in comments. I can attach files. She can even just close this out, by the way. Just close it without comment. Nope. It's a bit of a blunt way of saying no. Or she can just leave the comment. So then I can respond. We can have a conversation about it. Right? I can say, okay, sounds good. I'll get to work on blah, 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 blah. Or I can say something like, are you sure you really want me to do that? What's the motivation? Or I'm not sure I agree with that. What do you think, other developer? And then I can bring somebody else in and we can have a full discussion here as a team. Okay? I can even make more changes if she requests them. But then eventually, hopefully, my boss decides things are good to go. It's time to merge those changes in. So if she accepts my pull request, she can then go and click merge pull request and merge my changes, or whoever's in charge of doing the merging, merge my branch in to the main branch, the branch I was requesting, and then we're good to go. So she'll click that button, and then I'll demonstrate this for real, not just with slides. Then she can make the merge commit message directly on GitHub. So this is just a mechanism for merging changes in from a feature branch into some other branch, where instead of just going for it, we have this process where we can have conversations, we can chat with each other, we can make updates, request things, we can reject a suggestion or a pull request, or we can accept it. But if my pull request is accepted, the end result is still just my branch is merged into another branch. It's just a slower, longer process that is more transparent and more controlled, I guess, for merging. So that's an intro to the concept of pull requests. I'll wrap up by showing you that if we look at any popular repository on GitHub, there's going to be a section for pull requests. Like this is React, a very popular repository, lots of contributors. Those contributors don't just directly push changes up. They don't even have permission to directly push changes to any of the branches here. There's another way of making pull requests we're going to talk about involving something called the fork and clone workflow. That will be coming up in a little bit. It's a common pattern to contribute to open source projects where you're not an actual collaborator. You don't have permission to push. Anyway, we'll get there. But if we go to pull requests, we can see quite a few of them here. And again, there's a lot of structure and patterns that have to be followed when you're creating a pull request for a big open source project. So they all follow particular naming conventions. They all have these different tags. But you can see here's one somebody wants to merge one commit into master from their feature branch. Notice the name of this feature branch. Well, this is not a great one actually from Dependabot. If I find another one, how about this one here? So this is a pull request from the branch Rick Hanlon 2. Hanloni, I don't know. RH add effect warn test. That's the feature branch. Whatever he did on this branch, he wants to merge it into master. And then we see some information about what his pull request includes. He wants to add a test, so we can see under commits, here's the commit. We can view that commit, what's included, what's new. So some new code here. And then there's a discussion around it. So this person said, please, you should probably throw an error, like how blah, 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 blah. So it's a conversation, in other words. And this one is still open, meaning it has not been closed or rejected, but it also has not been merged. Oh, and there's a lot more conversation here around this PR. And that's kind of a good place to end, just to show you an example. So these larger projects have tons of pull requests. Sometimes it can take a little while to get yours. If it's not super important, if it's not a critical feature you're working on, it can take a little while to get noticed depending on the resources available to the project maintainers. Anyway, that's the basic idea of a pull request. I'll show you the workflow in the next video. So let's now try making a pull request. We'll use the same repository, the feature branch workflow for Colt and our chicken Stevie. So we have this navbar branch that Stevie already pushed up, right? We can see navbar right there. We also have the pricing table branch, but that's already been merged in. We didn't use a pull request to do that. I'm currently working as Stevie, and if we take a closer look at the navbar branch, there's this button here, pull request. So first we can do a comparison between navbar and main. Now, it assumes that I want to compare with main because that's a default branch, but I could make a pull request to some other branch if I needed to. I could make a pull request to pricing table, just not that common. So it tells me, all right, here's your comparison. Good news, we're able to automatically merge your branch navbar into main if we get to that point. So it's not going to merge without me clicking merge. Creating the pull request simply requests that merging. So we can see there's just two commits, right? We have the broken navbar, the navbar fix. Here's the diff. We can see all the stuff that I added in, or Stevie added in. Anyway, if I decide I want to make this pull request, I'll click that button, create pull request, and then I can put some title in here. It's just using the name of the branch. So how about add in bootstrap navbar? Okay, leave a comment. This is my comment. I can mention people, like I'll mention Colt. Please take a look. So that will actually mention him as a user. I can have bold text. I can put code in here. I can do all sorts of stuff, different formatting and formatted information. But I'm just going to keep it simple. So add in bootstrap navbar. This is my comment at Colt. Please take a look. Here we go. Create pull request. So from my navbar branch to the main branch. All right, so here's the PR. You can see under PRs or pull requests, we have one. It's open. It was created by Stevie Chicks a couple seconds ago. And we can also see the way that this repo is set up, Stevie can just merge it in. That probably is not the approach that we want to take. There are ways to restrict who can merge branches and organizations, or who can merge PRs. But for now, anybody can merge it in. So Stevie could make that PR and then also just turn around and click merge. But I'm not going to do that. Let's go switch over as Colt. So we'll refresh the page on Colt's computer. And then we have this PR showing up. I also got a notification up here. I dismissed it when I wasn't recording, unfortunately. But I got a notification for the fact that I was mentioned in this pull request. So I can respond to Stevie, right? I can decide, I can merge it right now if I want to. I can close it and just say this pull request is going nowhere. We're not adding this in to the main branch. Or I can leave some comments like, looks good or looks bad. Can you fix this or add this? Can you make this change? And changes can be added to a pull request after the pull request is originally created. We can continue to, like in this example, Stevie could continue to add to the navbar branch and respond to feedback. But for this demo, I'll do something like looks good. Whoops, didn't mean to do caps, but merging now. All right, so I'll leave that comment. I won't close it. So I haven't taken action, but now I'm going to. So not every pull request can be merged automatically on GitHub. Just like when we're doing merges locally with Git, not every branch merge is a fast forward, or not everyone it can be done automatically without generating any sort of conflicts. So what I'm doing here by clicking this button is telling GitHub, all right, go ahead and do the merge yourself. So then we're going to have some code that has been merged in on GitHub that we don't have locally. So the main branch is going to change. I'm going to click. All right, do I want to change the commit message? This is fine. Confirm merge. Successfully merged and closed this pull request. The navbar branch can now be safely deleted. So let's just delete it now. Okay. So now we have successfully completed one part of this workflow where we went from working on a feature branch, Stevie made it, and then Colt actually added a commit, he fixed a bug. We push that up to GitHub, we make a pull request. That pull request was merged in, and now if we look at our index.html, we have the navbar showing up on our main branch. So now other developers, everyone on the team, needs to go and get the latest changes. So to do that, and we could fetch, or we can just pull origin main. This is on Colt's machine. And now we should have the navbar showing up somewhere. There it is. We have all that navbar work from the navbar branch. Just take a look at it here. There we are. So it's not very nice looking, but that came from a branch that Stevie created and pushed up to GitHub. Then we made that PR, and then Colt accepted it, merged it in, and now individual users, collaborators need to pull down the new main branch. And we could do the same thing on Stevie's side. So we can get rid of the navbar branch. We'll switch to main first. We can remove navbar, so we can do git branch -d navbar to delete it. So now it's gone, locally and on GitHub. And now I can pull down the latest version of main. So git pull origin main. And our local main branch is updated. We have the navbar. I can just show it here. So there we go. We have the same end result, the same thing that we did to make this pricing table merged into the main branch, except we did it via a pull request, an intermediate step that is done on GitHub, where we can have discussion and debate as to whether something should be merged in. And that's our first intro to PRs. So in the last video, the pull request that Stevie generated was able to be automatically merged in with a single button click, right? We didn't have to do any merging locally on our machine. It was all done in GitHub, and then we just pulled down the changes. But that only happens sometimes, where the merge can be done automatically. Just like any merge in Git, there's always the potential for conflicts. So in this video, I want to show you how you can resolve conflicts when merging a pull request. Okay, so we need to first start by making a pull request that will generate a conflict. And to do that, and to do things relatively speedily, hopefully, I'm going to start by doing a tiny change as Stevie. So here we are as Stevie. I'm going to just, let's change the title here of the entire web page. So we'll imagine, we're doing some big task. We're working on a feature branch, but really we're just going to change the heading. So let's make a feature branch as Stevie. We'll call this, let me make this a bit larger. How about git, let's see, we're on main. Let's do git switch -c because we're not going to work on main. And then we'll call this new heading. Okay, so switch to a new branch, new heading. And now we can do some really basic work, like change the heading here. Where is that? Instead of an H1, I'm going to give it a class of display1, which is just part of Bootstrap. And let's see what it looks like. Okay, there it is. And then I'm going to change the text to be, I don't know, hey yo, world. Or how about, actually, this is coming from Stevie. How about just bok. Is that how you spell that? I don't know. Whatever noise my chickens make. It's like a most of the time. All right, so that's Stevie's change. So Stevie adds and commits this to the branch. So git add index, git commit -m, change heading to bok. All right, so now we can push that up, or Stevie can push this branch, git push origin new heading up to GitHub. Then simultaneously, I'm not going to go through the whole workflow of making a PR as Colt. I'm just going to do some changes on the index directly on the main branch, which normally, we should be consistent. And if we're going to enforce pull requests, I guess I'm the owner of this repo, so I can do whatever I want. But normally you follow some rules, right? You're not going to have two sets of rules. You're going to ask everyone to use PRs to merge changes in. But just to demo this faster and not lose your attention, I will directly edit the file on GitHub as Colt, right? So I can just edit a file and make a commit on the main branch. So I'm going to edit this instead of saying hello world. Where's that heading? Right, wait, here it is. Instead of hello world, I'll do hello there everyone, and maybe a bunch of exclamation points. Okay. Then I'm going to save that. Well, not really save it, but I'm going to make a new commit. So update index, sure, that's fine. Commit directly to the main branch. Here we go. So now the main branch has changed, and Stevie has a branch that was pushed up. This is still kind of a trivial, a silly way of creating a conflict, but there should be a conflict now where if I try and make a pull request as Stevie, I'll take a look. Here's my new heading branch. Let's make a pull request. Uh-oh, can't automatically merge. Don't worry though, you can still create the pull request. So hopefully you see why we can't automatically merge. There's a conflict. Just like if we tried to merge these on our machine with git merge, it's the exact same mechanic. So if I want to make a pull request to change the heading to bok bok, I am a chicken and I changed the heading to say bok bok. I hope you like it. Okay, so I have a message. I'll create that pull request from new heading to main. And we see that there are conflicts that can be resolved. So the way that our repo is set up, anybody who's a collaborator currently can resolve conflicts, right, and merge a PR once that's resolved. I'm going to do it as Colt, though, not as Stevie. That's a more typical workflow, is somebody submits the PR and then it needs to be reviewed. So I'm going to go back to Colt's workspace, and then we see there's a new PR. Here it is. And if I want to merge this in, unfortunately, it's not as simple as clicking a button. So I can do a couple of things. If I click the Resolve Conflicts button, it actually gives me an option to do this in the browser, which I haven't really done before. And this, actually for this example, is super easy to do it that way because it's just a single line that we're keeping or combining. But rather than doing it in the browser, I'm going to show you the good old-fashioned way of doing it that you would do if you had a bunch of files. This is just one conflict in a single file, but in the real world, you may run into conflicts across a bunch of files. Hopefully not too many, but still, it might be easier to resolve them on your own machine. So we can click this, View Command Line Instructions, and it tells us exactly how to do this on the command line. So first, we need to bring the changes in so we can fetch origin. So we'll do that on my machine as Colt git fetch origin. All right, so now we have this new branch reference, this remote tracking branch. Let me make this larger again. Oh, well, that didn't work. Try that one more time. Here we are. You can see origin/new heading. So the instructions now tell me to check out new heading. They're using the checkout command on the Git or the GitHub website. They don't use git switch yet, which is the newer way of doing it. So we could do this. We're saying, make me a new branch called new heading and have it track origin/new heading. Or the easier option is just git switch new-heading. And it will do that for us as we've seen. So now that I've done that, I can see here, I should have bok bok showing up in the heading, and I do. I have Stevie's changes. I am currently checking out, I'm switching, or I have switched to that new heading branch that Stevie pushed up. So now I need to merge in the main branch. So this approach is switch to the new branch, the feature branch, and merge main in to the feature branch, resolve the conflicts there. So just test things out and make sure it works. And then when we're ready, we're going to switch over to main and merge new heading in. All right, so let's try that. Git merge main. This is the main branch. We know that there's likely going to be a conflict, although I think I'm missing the latest changes from main. Yeah, it's up to date because I didn't pull down. So let's switch to main. I'll show you what I mean, git switch main. Remember that I updated on main on GitHub. I changed the heading, and it actually tells me that your main branch is behind origin/main. So we'll do a git pull origin main. Now we have the latest changes on main. Now I can go back to new heading, and then I can merge main. So git merge the new main branch that we have. Well, it's not new, but the latest version, the latest work, merge that into this new heading branch. Now we have the conflict. So now I can resolve the conflict here. So maybe I want both. Maybe I want h1 class equals display1 from Stevie. And then I want, I don't know, all these exclamation points. How about bok bok everyone? Like that. So let's see what that looks like. Let's refresh. Okay, great. So now we need to add and commit the changes. So git add index, and we'll just do a useless commit message like resolve conflicts. Okay, so now we've merged the changes in, but we're just on the new heading branch. So we've made it, we know for sure that the current version of master or main works when we merged it in with the changes on new heading. We resolved the conflicts. Now we can switch back to main. And then we can merge in that new heading branch that we already resolved the conflicts on, which is exactly what they ask us to do or tell us to do on GitHub. So go back to main and then merge in new heading, which already has the conflicts resolved. So we shouldn't get new conflicts. Now this -- no ff, that's an indicator that we're telling git merge to not fast forward if it detects that it can, because when we do a fast forward, instead of making a merge commit, as we've seen, Git will just move the branch pointer to some new commit, right? It just moves forward. And sometimes we want to prevent that from happening, especially when we want to preserve or maintain our specific branch. We want to make it clear that there was a branch merged in here just to have that history. You don't have to do this part, but it's just what GitHub recommends. So we could just copy the entire line. We're merging new heading into main. Okay. So see, I'm now going to put a commit here instead of just a fast forward. I'm putting a merge commit in because I said no fast forward. All right. And now we just push up to master. Git push origin main. I said master again. We're using main. Git push origin main. All right. So now if I refresh this page, it automatically I didn't refresh, but it automatically detects successfully merged this PR and it's closed now. And you can delete that new heading branch if you want. Sure, let's delete it. We can also restore it if needed. And now we merged a PR in that had a conflict. And the same process would apply if there was one conflict or tons and tons of conflicts. We make a pull request and then resolve the conflicts following the instructions. Basically, pull that code down or fetch it, check it out or switch to the new feature branch, merge master or main in, resolve conflicts, add and commit, then switch back to master or main, merge in the now conflictless branch, and then push that up. Okay, so now the last thing to do is, as Stevie, go and get the latest version, right, of the main branch. We don't have that as Stevie, so we just need to pull down. We'll switch to main. We can remove that branch now. New heading, so git branch -d new heading. And now git pull origin main. We'll get the latest changes from main. And there's not a whole lot that we got, but if we type git log, we see, okay, we got the resolving of the conflicts, merged that branch in, my work was merged in. So now our latest version of the main branch says bok bok everyone. And we can take a look at it right here. And there we are. So we successfully merged a PR in that had a conflict. Okay. So another thing we can do if we're working on a repository with collaborators is add in branch protection rules. So if we go into settings, assuming that you are somebody who has access to settings on the repository, under branches, We have, first of all, the default branch. You can configure this. So if you want to make it something else, for example, if you have main and master and you realize you only want main to be the default, well, I shouldn't say only, you can only have one default. So if you want to switch that to main, then you could do that here, but we already have main as ours. Or if we needed to change it in some way, you can change that default branch. But then down here, it says branch protection rules. Define branch protection rules to disable force pushing, prevent branches from being deleted, and optionally require status checks before merging. New to branch protection rules, learn more. So we're going to add a rule. We're going to protect our main branch. The first thing it asks is for a branch name pattern. Now, instead of just a branch name, it gives us the option of putting a pattern in here because on large projects, there may be thousands of branches that are pushed up or pull requests generated from. And the organization or the project enforces rules where they need to be something like /feature/blah or /release if it's a big release of, I can't spell release, but there are different patterns and you can define different rules for those different types of branches instead of having to name each one. But we're not going to do that. We only have our main branch, so we'll just put main in there. And then I'm going to do this, require pull request reviews before merging. This means that our commits need to be made to a non-protected branch, basically not main, and then submitted via pull request, and then at least one person, which is, we've only got 2 here, so only one person needs to approve the PR before it can be merged. So I just want to demonstrate how that would work. There are other things, right? Do we allow people to delete matching branches or not? But we're just going to go with require pull request reviews, so create. So now we have this branch rule that applies to one branch, main, it is protected. So if I try and act as Stevie, so I'm logged in as Stevie here, and I want to make a change to the main branch. First of all, if I try, let's update even just the README directly on main. I'm going to start editing this. So feature branch workflow, how about Bach. Okay, I'm going to try and commit this. And take a look, it says you can't commit to main because it's a protected branch. Earlier, I showed an example of this, and we could just commit directly to main, but now I can't. So it wants me to make a new branch and start a pull request. So I'm going to do it just in the browser instead of doing it locally. It would be the same exact process, though. I make a feature branch, make my changes, push up the feature branch. So this just makes me a feature branch, and I use the default name it gave me, Stevie Chicks patch 1. All right. So now I can make my PR from Stevie Chicks patch 1 to main, and I'm going to create that PR. But I can't merge it. Look, merging is blocked. Earlier, when we had made PRs as Stevie, I showed you that I could just merge it in myself. There's nothing preventing me from doing it aside from being a trustworthy developer. I could make a PR that did something bad and broke master or broke the main branch and just merge it in. But now, because of the protection rule we set up, we need at least one approving reviewer. So I'm going to go as Colts and be that approving reviewer, hopefully. So here is that PR. It says it needs a review, so I can add it if I want, or I'm an administrator, right? I'm the owner of this project, so I could just directly merge it. But I'm going to add a review. So adding a review is super simple. If I'm good with it, I can click this, but I can also add a note, a comment about things and say like, always with the Bach, Stevie, get a new catchphrase. I'm joking around here, but we can add things in like that. We can then start a review. So I can just add a single comment if I want. Stevie will then be able to see that over here. You can see it shows up for Stevie. I reviewed it. It says always blah, 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 blah. He can respond back to me. Bach. Now I go back to my side. I may need to refresh here. There, we see Stevie's response. Okay, so now I'll click review changes. I can finish the review and I can approve. So I can approve merging the changes, or I can request that he makes additional changes, or I can just leave a comment without actually approving it. But I'm going to approve now. So that was the review. It's still not merged in. So now at least one person has approved it, which is the rule we set up. You can have it be more. You could have 2, 3, 4, however many people you need to approve it. There's all different fancy permission things you can get into, especially if you have an organization set up or an enterprise account. Anyway, now I can merge that in here, right? That wasn't showing up before, so I'm just going to merge it. It's a very silly change to make, and I'm going to confirm that merge, and that will close the PR. We can delete that branch, and now the master branch, that README, contains Bok at the very bottom. Okay, so silly little example, but I wanted to show that we can set up these protection rules, and they're very, very useful, especially if you have a bunch of people working on one project together and they're making a lot of pull requests, and you want to be able to have some quality control or some feedback process in place where people can't just directly change the main branch. They instead are asked to make a pull request and then get feedback from at least one person. Okay. So we spent a lot of time talking about pull requests, but it's a very important feature, and it's actually going to come up again in this next workflow I'm going to introduce. I'm calling it fork and clone, or forking and cloning. It's a different approach to what we've seen so far. So this is a workflow where instead of just one centralized repository on GitHub, every developer has their own GitHub repository in addition to some main centralized repo. And then individual developers can make changes and push to their own versions, their own forks, before making pull requests. So I'm going to diagram all this, and hopefully it makes sense. The whole point of this is that large open source projects with lots of contributors, maybe thousands and thousands of contributors, they often employ this strategy or this workflow where there might be a handful of actual maintainers and owners of the project. They're not adding thousands of people as direct contributors. Like we saw, with an invite where I could invite Stevie. I manually went in here, where was that? Manage access, and I invited Stevie. So they're not doing that for every single person who wants to collaborate on React or TensorFlow or something. Instead, this workflow, this fork and clone workflow, enables anybody to try and make a contribution. You don't need permission. You make your own copy. You try making changes, and then you make a PR. Anybody can make a pull request. So the first concept to understand is forking. Forking is a feature that is not part of Git itself, just like a PR is not part of Git. It is a feature of GitHub and other similar hosting services for Git repos. When we fork a repository, it creates a personal copy of somebody else's repository on our GitHub account. So we would call the new copy a fork of the original repository. So when I click the button to fork a repo, I'm asking GitHub to please make me a personal copy of this repo. This only works if it's a public repo and we have access to it, or I guess if it's a private repo, you can fork it if needed, but you still need access to it. So I'll demonstrate this. I want to be clear again, this is not a Git feature, it's part of GitHub. So on some repository, this is, for example, not my repository, clearly, Automatic Udemy Course Enroller, get paid, Udemy courses for free. I don't even know if this is still up or not. But this is not my project. But if I want to work on it, I'm not a collaborator. Instead, I'm going to click this fork button right there. So when I do that, notice what the URL or the, what would you call this? I guess the breadcrumb is somebody's username / the repository name. When I fork, I click that button, now we have a copy that is on my account, Colt / automatic blah, blah, blah. So I still have all the history, all the files, but I can do my own stuff on here. I can clone this, I can delete branches, I can completely break code. It's totally up to me. It's just my repo now, and it's just based upon the original. So here's the two side by side, the original and then my fork. It shows my username, but also it says where I forked it from. And that's just an intro to the concept of forking. In the next video, I'll demonstrate it, and then we'll talk about how we can use this concept to make open source contributions. So now I'm going to demonstrate forking and cloning, because all that forking does is it makes us a copy of a GitHub repo on our GitHub account, right? It just makes a copy that we have access and permission to do whatever we want with. But that doesn't mean we have it on our machine. So the demonstration repo I'll be working with is this 2048 repo. We actually cloned it a while ago when I first introed cloning. It's for this very addictive 2048 game. It's just a single HTML file, some JavaScript, some CSS. Anyway, I can clone it right now, just like any other repository. But if I clone that and make changes and make my own commits, I can't push those up, right? I don't have permission unless I ask to be a collaborator somehow. That's not how this works. That's not how GitHub works. So instead, if I want to make my own changes and push them up to GitHub, maybe just to show other people, let's just start there. I want my own version on GitHub where I can totally screw things up and share it with people, maybe even add my own collaborators. I want to work with my friend, I don't have friends these days, my friend Llama Lady. I want to work with her on our own version of 2048. We'll use this as a starting point, and then I will fork it, or she can fork it, and then I can add her as a collaborator. So I'm going to fork it to my personal account. It takes a moment, but we should, well, you can already see Colt/2048. My own copy, I have all the files, I have all the history, but now I could do things like add my own collaborators or change the access, protect a branch, delete branches, whatever I want. So now I can clone this down to my machine. So I could clone the original too, right? There's nothing stopping me, it's a public repo. But if I clone this one, when I clone it, the remote will be set up for me automatically so that I can push up to here. Versus with a cloned version of the original, if I clone this, I can't push up to origin because origin will be Gabrielle Cerulli. That will be this account, right? I can't push to this repo. I can push to this one. So I'll copy that URL and then I'll clone it down to my machine. So let's get out of here. Git clone. All right, so we have that new directory. 2048, git status, cool. We see all the files, and let's do git log. I see the full history, lots and lots of commits, but also if I do a git remote -v, you can see that origin is set to my own fork. This is my repo on GitHub, not the original. So now I can do whatever I want. I can diverge and make some serious changes. So let's open this up. So here it is in the browser. Just the file, index.html. I'll make some very simple changes, a single commit. Let's go with, 2048 forked like that. Not an exciting change. Oh God, that really screwed things up, huh? Okay, well, let's go with 2048 and keep it like that. Well, maybe we'll just change some styling then. Very simple, new background color. Okay, well, I fast forwarded a bit. I modified some of the CSS. So now this is what the game looks like. I didn't really do anything worthwhile, but you can see, the colors have changed a little bit compared to the original, which looked something like that there. Not for the better necessarily, but I've changed some CSS. Okay, so I can make those commits and do whatever I want locally. So this is my local Git. I can make a commit on the master branch, which is where I am by default, or I can go to some other branch, git switch. I'll just commit directly to master, I guess. Git add dot, git commit -m, change color palette. Cool. So I have that changed locally, which I could do on any repo, whether I cloned it or forked and cloned. You have permission to make commits on your own local repo. But what I don't have permission to do, unless I own the repository or I've been granted collaborator privileges, is push, as we already know. So I own this repository because I forked it. So I can push up and push that new change to my fork. Git remote -v. So if I push my master branch to origin, just like that, git push origin master, now my new commit is on my fork. And we see change color palette, right? All the other commits are like years and years ago, and then 36 seconds ago. So that's just on my fork. It has nothing to do with the original project. Aside from the fact that I made my own copy of the original project and made changes to it, but I'm not working on this original repository. I'm working on my fork, and I can do whatever I want. I can add somebody else on here. We can collaborate. We can destroy this without ever impacting the original, without needing permission. That's the whole point of forking. So in the next video, I want to talk about this workflow that stems from the ability to fork, where we can fork and then collaborate on an open source project or just as a team with a bunch of forks and a centralized repository. So by forking, we've made a copy of the repository that exists on my account on Colt, and I've made some changes locally. I push them up. We see the changes. We did this in the last video. Where is that commit? Basic? No, not basic. Here it is. Change color palette on this style directory. Anyway, I have some work, and it actually shows I am one commit ahead of the original repository that I forked from. So GitHub is actually telling me automatically, hey, you have some work on your fork that is not on the original. And I can just ignore that and never do anything with the original. Or I can actually share my work or attempt to share it by making a pull request. I can make a pull request from my fork to the original repository. So I'm not going to actually go through with it because I don't want to bother the creator of this repository with a dumb, useless pull request that they'll just close. But you can see it's the same interface. I can create a pull request with my changes. I can leave a comment. I can explain why. Why I think this should be merged in. And then the repository owner and anybody who has merge permissions can then take my pull request and merge it in or close it or whatever they want to do. So that mechanism is really, really important. This would be a way for me to make a real contribution, not the silly one that I did, but I could make a real contribution to a project that I don't own. I don't have permission to push to it, but I can fork it. I can make my own suggestions, my own changes, and then open a pull request. And that's the basis of this workflow. So this workflow, I'm calling it fork and clone. Other people say fork and clone. I'm pretty sure it's not some official term, but it's common enough. It allows a whole bunch of people to work on the same project without actually all having permission and write permissions for the same repository. So I have some diagrams that I'll be using to illustrate how this all works. If we have 3 collaborators, which is just a subset. Let's say we have way more on a big project, potentially thousands of people who want to collaborate. But here on the diagram, I've only included 3 people. Me, somebody named Taylor, and somebody named Lupe. And then we have the official project repository. Maybe we're working on React or some big repository that we don't have access to directly push or change settings. We have to make a fork. So we each fork, that's what the fork is representing. And then on my local machine, I clone my fork. So that's what this is indicating. So I have my fork that I made from the original project repo. I clone that down. So now I have this automatic remote setup called Origin, just because I cloned this repository. The default remote name is going to be Origin. So Origin refers to my fork. That's done automatically when I cloned. But then I'm going to set up a second remote. And this remote is going to be anything I want, but normally we would call it upstream. That's a very conventional name. And it refers to the original repo that we forked. So this allows me to basically have a place where I can do my own work and push changes up to. But also, if there are changes made to the original repository on a large open source project like React, there might be new commits and pull requests merged daily. I want to be able to get those down on my machine. So even if I can't push up, I can still pull changes down. So often upstream or original will be the name of this remote. But now we have 2 remotes, one going to my fork and one going to the original. So now if I do some work, I make a new commit or a bunch of commits. Normally this would be on a feature branch, but for the diagram's sake, I'm just doing it on the main branch or whatever this branch is. So I make some work or I make some commits. Then if I want to try and share it with the repository creators, I definitely cannot push up because I don't have permission. So instead, I can push up to my origin, which is my fork. I can push whatever I want up there. I could make the whole thing empty. I have permission to do anything with that because I own that fork. So now on GitHub, I have my fork that I've worked on, and I can make a pull request, just like what I showed you here, where I forked 2048. I can make a PR and ask for my changes to be merged in. So then if I do that, open up a pull request, then it's up to the original or the official project repo owners, somebody who maintains it, who has permission to accept, to merge, or close my pull request. And if my pull request is accepted, it's merged in. So then the next step is basically show up at work again and pull down my changes from upstream. So there's new work that was done on upstream. I don't have it locally. So I go and get the latest from the real repository. I pull that down, and then I can do some more work locally, push that up to my fork, and then from my fork, make a pull request when necessary. So the whole point of this workflow is to allow people who don't have direct access, direct permission to push or to change anything in a project repository. They can still collaborate. They can still make pull requests by forking and then pushing their changes to their fork and opening a PR. So this would be the sort of cycle. We pull down the latest changes from the official repo. That's one remote. We make changes. We push them up to our fork. And then we can make a pull request if we want with suggestions or with our changes that we want to be merged into the original repo. And then we just wait and we hope that someone responds. So here's a short summary. Fork the project, clone the fork, add our upstream remote, do some work, push to the origin, and then open a PR to the original or the upstream. So I'm going to demo that again in the next video. We'll wrap up by just talking about why this is a good idea in some situations. This is not a workflow that you may want to use like on every single project that you're working on. But again, at a larger scale, where there might be some project that thousands of people might be interested in working in, or even if it's just 2 or 3 people, but you don't want to give them access directly to your repository, people can still make these suggestions. They can make their own changes and hope that you merge them in. They can make a pull request from their forks. So this allows us to work with tons and tons of people without having to have direct collaborators added to a repo. So now I'm going to demonstrate this fork and clone workflow on very, very simple terms, but the workflow is the same. We're just going to work on a very silly repository. So as Colt, one GitHub user, I'm going to make a new repository. And I'm not going to give anybody access, I'm going to make it public, of course, but I'm not going to make anybody a collaborator. So nobody will be able to push to this. I'll just call this fork and clone maybe. Fork, and clone. All right, it's public. I'll put a README in there, okay? And then I'll create this repository. Okay. So now I'm going to just add, I have my initial commit. Maybe I'll do one more commit. I'm just going to do it on GitHub to keep things simple. So this is a repo to demonstrate the fork and clone workflow. Sure. Okay. We'll commit those changes to the main branch. And there we are. Okay. So the next thing that I'm going to do is change people. I'm going to switch over to Stevie, pretend I'm Stevie. So here we are on Stevie's GitHub. I'm logged in as Stevie here, Stevie Chicks. And if I go look at Colt's repositories, I hate looking at this, I can see fork and clone. Okay, so this is the original project. I don't have access, I can't edit things. I mean, I can view it because it's public, and I do want to collaborate. Let's say I want to, I don't know, I'll add some changes, I'll make a new file, whatever it is. There's some change that I want to work on and suggest. So I'm going to fork this repository as Stevie. So instead of Colt/fork and clone, hopefully we end up with Stevie Chicks/fork and clone. And it takes a moment, but when it's done forking, there we are. I now am going to copy this URL and clone this as Stevie. So over here, let me clean this up a bit. Okay, so I'm Stevie here. I'm going to back out. Sure, I'll just clone it right here. Make sure I'm not in a repo. Git clone that URL. Excellent. So now we have this fork and clone repository. Very simple, single commit, no, 2 commits in there from Colt Steele. And now I have cloned it. But if I look at my remote, I cloned the fork. So that remote is just pointing to my fork, not to the original. So I can push changes up. I can do that right now if I wanted to. But before that, I'm going to just set up a second remote. And the reason for this, if I go back to my diagrams, is that I also want to be able to get changes that Colt might publish on the original project. Because my fork is frozen in time. I don't get changes from the original project after I create the fork. They are forking. They diverge, right? So if I want to stay up to date with what's happening and I want to get those changes on my repo from Colt's original, then I want to have a connection. I need a remote to refer to that original project repo. So I'll just go to the original. So this is the original project. I'm going to copy this URL, for Colt's version. All right. And then I'm going to add a remote. So it's git remote add. And then I'm going to call this one upstream because that's a really common name, or original or something to indicate this is the original thing I forked and cloned. This is not my repository. So I'll just go with upstream. Okay, so now if I do git remote -v, we have two remotes. I know it's kind of hard to see them here because they're not on one line. Let's make that full screen. Here we are. Origin goes to Stevie Chicks, upstream goes to Colt's version. Okay, so now I'm switching back to Colt for a moment. Let's suppose that during all of this couple of minutes while Stevie has been forking and cloning, I'm working on this project as well. And again, I'm just going to do a very silly, simple change. I'm going to edit this. What should we put in here? Fork and clone. How about this? My favorite ice cream flavors. And then we'll do, in no particular order, mint. Well, my actual favorite is peppermint, but that's not that common. And then we'll say mint chip. And then let's just leave it at that for now. All right, so there's my new commit. I'll go with add ice cream to readme. Commit changes to main. So this is happening on Colt's original repository. Stevie's fork doesn't have that. They diverged. They're not in sync anymore. This is a fork from a moment in time. So they're not attached. However, I can still get those changes because locally I have those two remotes. So if I want the latest, let's just make sure get status. Okay, everything's up to date with origin. But if I want the latest from Colt's repository, I can do a git pull, and then the remote is upstream, and then whatever branch I'm looking for, I want main. So I'll pull down from upstream, and if I do a quick git log, we see we have ice cream now, add ice cream to readme. So now I could make some more changes on this potentially. Like let's say, what would I want to do? If I just open it over here in my text editor, here's the readme file. Let's do something like Stevie's favorite ice cream flavors. And then Stevie is a chicken, so Stevie really likes mealworm, maybe like shrimp flakes, and sunflower seeds. Okay, so we make a change. We'll add that commit. So git add readme. I'm doing this all as Stevie, blocking that, but I'm working as Stevie the chicken right now. So git commit. Let's do something like add Stevie fave ice cream. Okay, not a great commit message, but I'm trying to keep this quick. Okay, so if I want to make a suggestion to the original project that they include this new commit that I've made, or whatever, multiple commits, first of all, normally we'd be working on a branch. I mean, we are on a branch, but we'd work on a separate branch, a feature branch. Just to keep it simple, I'm just working on main as well. So I don't have permission to push this up to upstream, but I do have permission to push to my fork. So that's what I'm going to do. Remember that my fork I labeled, well, I didn't label, but the default name for that remote is origin. Make that full screen as Stevie. This is what I can push to. I'm not allowed to push to this. I don't own it. I don't have collaborator privileges. So I'm going to push up to origin. Git push, and then we'll do origin. And then main is just the branch we're working on. And when that finishes, I should be able to refresh on my fork as Stevie Chicks. And we see Stevie's flavors are down there. But the original does not have it. So you can see I am one commit ahead of Colt's version. If we just open that in a tab, this is what Colt's original version looks like. So we now have this work that we could suggest. And that's exactly what I'm going to do. I'm going to open a pull request. That's the next step in this diagram, right? So we make our changes, we push them up to our fork, and then I make a pull request to the original project. So as Stevie, I'm going to make that pull request. Thankfully, it's a very easy one to merge. I'm going to ask, please allow this in. Please, I'm just a little chicken. I want to make this PR. Bok bok. All right. So then I'm going to create pull request. Take a look here. Specifically, I'm going from main to main. It's not that common. Normally, we'd be working on a feature branch. We saw how to make a pull request from a feature branch in the last, a couple of videos ago. So it's the same process. You just change the branch. We just don't have a different branch to pick from right now. So from my fork to the original, main to main, here's my comment, please. Here's my pull request. All right, so I can't merge that in. I don't have access. I'm not the decider, but I just wait here and I hope that I hear back, maybe some feedback. I hope it's not just closed, but it may be. Now, as Colt, I'll go to pull requests. I'll refresh and we should see a new pull request. And here it is. I am the only person in charge. I get to review and decide if I want to merge this in or not. And let's say that I'm happy with it. So I will merge it in. Confirm. Now I have successfully merged in that pull request. So that means that fork and clone on my account, Colt, now has the new information from Stevie's. And so now we have completed this cycle at least one time. So Stevie made some changes, pushed them to the fork, made a pull request. The pull request was accepted and merged in. And so now this original repository has Stevie's changes. So this process is all over the place with open source development. If we just take a look at any big Git repository, let's take a look at, here's React, right? We can see lots and lots of contributors, used by millions of people. And if I go to pull requests, I showed this a while ago, lots and lots of pull requests. And if we look at where the pull requests are originating from, let's just pick any of them. It doesn't really matter. Sure, this one. Notice that it says this person, Ari Perkio, wants to merge one commit into Facebook master branch from Ari's particular fork and then a feature branch. So notice the prefix, right? Facebook master versus Ari Perkio. Sorry if you're watching this, Ari, you're probably not watching this. But anyway, that's a fork. So this is a fork that was made, and we can go take a look. Here is that fork. This is Ari's fork of the original React, and they made a pull request. And now they're just waiting. They're not even just waiting. There's a conversation happening about this pull request, but it's still open. So that's the basic workflow, and that's how all of these contributors are making their contributions. They're forking and then making a pull request over with their changes. And then to stay up to date with what actually changes on the official repository, remember this step, pulling down to get the latest changes from the official project repo so that you're up to date with the work everyone else has merged in.